Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about statics of rigid bodies. In today's discussion, we shall be having belt friction, where the first part shall be the derivation of the formula for belt friction, and in the later part, I have prepared sample problem on how we can use the formula in belt friction in solving problems. Magsimula tayo guys sa isang assumption na we have here a fixed drum. And on the fixed drum, ay merong belt which is wrapped around this fixed drum at a certain angle, where the angle is defined by the points of intersection between the drum and the belt. Assuming natin that these 2 points shall be the points of intersection between the drum and the belt, and that angle subtended by the belt from this point up to that point is defined by angle beta. Imagine natin that the belt will be moving against the drum in this direction. And because there is a friction between the drum and the belt given by the coefficients F, therefore, as the belt moves in this direction, there will be a frictional force that will be developed directed in the opposite direction as the direction of the motion of the belt against the drum. And for the belt to move in this direction, it has to overcome the frictional force that will be developed between this belt and the drum. Hence, we expect that the tension at the ends of the belt shall be different, with the tension in this direction, in the direction of the motion of the belt against the drum, be greater than the tension on the other side. If we are going to define the tension on this side in the direction of the motion of the belt against the drum, be called as T sub T, which is being used to refer to as the tension in the tight side. And the tension on the other side be called as the tension on the slack side, which shall be referred to as T sub S. Our concern is to define the relationship between this tension on the tight side and the tension on the slack side as the belt moves in this direction. Let us consider a differential element defined by this d sub s, and this d sub s subtend a very small angle d theta, and that angle theta be defined from the point of tangency between the belt and the drum in the side of the slack side of the belt, such that this theta is defined by this. Now, if we're going to consider the differential arc ds as free body diagram, let us try to take that as free body diagram, and let us try to imagine that this be enlarged for the purpose of discussion. This angle theta is subtending an angle d theta that is very small, and the direction of the motion of the differential length, differential arc of the belt be defined by this motion. Due to this roughness coefficient between the belt and the drum, there is a very small friction developed between them. And as such, the tension on the side of this belt shall be different from the tension on the side, and their difference is also very small. Let us define the tension on the sides as T, while this one shall be defined as K, T plus dt, where the dt defines the difference between the tension on the tight side and the tension on the slack side. The frictional force developed between the belt and the drum is dependent on the magnitude of this very small normal force exerted by the drum against the belt. And let us imagine that this is d sub n. If we will be defining an axis that is perpendicular to this d sub n, therefore, the angle that these tensions on the belt can be defined in terms of this angle. And by taking the relationship, this angle will be 1/2 of the subtended angle between the drum and the belt. And therefore, if this is the d theta, therefore this will be 1/2 of this angle, and therefore this is equal to d theta over 2. This is also equal to d theta over 2. Then if you're going to consider an axis perpendicular to this x-axis or in the direction of the normal axis be called as y-axis. Therefore, if we will be summing up forces in the y direction, we can solve for the relationship between d sub n and these tensions on the slack side as well as the angle theta. So that summation of force along y gives us an equation equal to, assuming that the upward direction be positive. So I will have d sub n minus the y component of this tension, which is equal to t sine of d theta over 2 minus the y component of this tension, which is also equal to t plus dt times sine of d theta over 2 shall be equal to 0. But for a small angle, d theta, expressed in terms of radian, then sine of d theta over 2 is approximately the same as d theta over 2. Kaya kung simplify natin ito, sasubstitute natin itong d theta over 2 dito sa function na sine of d theta over 2, then our equation becomes dn minus t times d theta over 2, because sine of d theta over 2 is approximately the same as d theta over 2, minus t plus dt times d theta over 2 equal to 0. If this d theta over 2 shall be distributed to the term inside t plus dt, then the product of the two small quantities dt multiplied by d theta over 2 will approximately be equal to 0. Hence, the equation can be simplified further into dn minus t multiplied by d theta over 2 minus t multiplied by d theta over 2 equal to 0. And if these two shall be added and then transposed to the right-hand side of the equation becomes dn equal to t multiplied by dt. Now, from the equation that this frictional force shall be equal to the product of the coefficient of friction multiplied by the normal force. Therefore, we can substitute the value of dn, which is equal to t multiplied by dt in this equation. Therefore, this equation becomes dt multiplied by f multiplied by the quantity t multiplied by d theta. If both sides of the equation shall be divided by t, then the equation becomes a differential equation which is equal to dt over t equal to f multiplied by d theta. Now, if this differential equation shall be integrated, therefore this becomes the integral of dt over t shall be equal to f multiplied by the integral of d theta. And how are we going to integrate it? We integrate it with the limits of t from the side. Okay, imagine natin that we have here our limits of integration. We integrate it from this side at the point of the tangency between the drum and the belt up to the other side, up to the tangency, point of tangency between the belt and the drum, such that at this point, our theta is 0 and the tension is t sub s, while at this point, our theta is already equal to beta and the tension is already equal to t sub t. Therefore, our limits of integration shall be the integral of dt over t evaluated from t sub s to t sub t, whereas the limits of integration of d theta shall be from 0 to beta. And if this will be integrated, we will have the ln of t evaluated from t sub s to t sub t shall be equal to f multiplied by theta evaluated from 0 to beta. If the limits of integration shall be substituted in the equation, then this becomes equal to ln of t sub t minus ln of t sub s shall be equal to f multiplied by beta. And if this will be simplified, applying the property of logarithm, then this becomes equal to ln of t sub t over t sub s shall be equal to f sub b, which says that the ratio of the tension on the tight side to the tension on the slack side is equal to E raised to the coefficient of friction and subtended angle between the belt and the drum. To show an example how this formula can be used in solving problem, then let us try to have the sample problem. This sample problem is taken from the book of Singer, and the problem goes like this. A rope is looped over two fixed posts, each 12 inches in diameter. If the coefficient of friction F between the rope and the post is equal to 1 over pi, determine the maximum and minimum values of P that will prevent motion of the loads W, which is equal to 1,000 pounds. Yung sinasabing maximum value of P in the problem is that it is the P that is about to lift the weight. Yung bang P na halos may hila mo na pataas itong W. And to give an example, to show an example how this will be shown, let us imagine that we redraw this figure in this manner, and let us show how we will be showing the maximum value of P that will lift, that will start to lift this weight W. And this is how it will be shown. Okay, ganyan yung mangyayari. Magmumove siya pababa, mahihila pataas, and then the cable will be rotating against the fixed post in this direction. Iikot siya in that direction. And to start that motion, we will be needing a certain value of P, and that P, yun yung tinatawag nating maximum value of P that will prevent motion of the weight W. Samantalang yung isa namang tinutukoy na minimum value of P dito na sinasabi is the value at which the weight is about to move downward. Siya naman yung P na magpe-prevent ng motion itong W in the downward direction. And to show it, ganito yung mangyayari. Ayun. Diba? It is the magnitude of the P that will prevent the weight of W from moving downward. And we are looking for those two values of P. Now, to solve for this, let us try to start with defining the maximum value of P that will prevent motion of the weight W. And let us consider the entire structure as free body diagram. And from here, let us try to imagine defining the property or the dimensions of it so that we can define how much the angle that this rope is making or is subtending against the two fixed posts. Okay? If this will be directed in that manner, let us try to identify the weight or the dimensions. The dimensions that from these 2 points, the dimension is equal to 24 as indicated in the problem. So that mula dito hanggang dito will be 1/2 of 24, and that is equal to 12. At mula naman dito hanggang dyan shall be also equal to 12. Yung point of intersection between the lower post and this drop in this belt shall be from this point up to that point. Pakita natin siya. And we will be calling this as angle beta. Itong point of intersection shall be at the point where the cable is perpendicular to the line joining the center and the point of intersection between the belt and the drum. Similarly, on the second drum, because if the cable runs this direction, it will have a point of intersection here and also another point of intersection there. So that these 2 points shall be called as the 2 points of intersection in the other drum. And we can define that as, okay, tawagin natin siyang beta sub 2. Similarly, as the cable runs that direction, it will again meet the drum at this point and then leaves the drum at that point. So that is the 2 points of intersection. Okay? And the angle that is subtended by this shall be called as beta sub 3. Now, if we're going to solve for the subtended angle beta sub 1, beta sub 2, and beta sub 3, you would notice that the relationship between theta and beta is that they are complementary angle, and therefore beta shall be equal to 90 minus theta. Now, to solve for the angle theta, let us try to imagine this triangle, and consider natin siya as FBD. And this triangle have the following side. This side of the triangle shall be 12 as indicated in illustration, while this side of the triangle is equal to the radius of the post, which is equal to 6 inches because the diameter of the post is 12 inches. And this theta can be defined by these two sides so that theta shall be equal to arc cosine of 6 over 12. Or simplifying, theta is equal to arc cosine of 0.5. Solving for the angle theta, theta shall be equal to 60 degrees. And therefore, if this will be substituted here, we can solve for beta, and beta becomes 30 degrees. And if beta will be expressed in terms of radian, this angle will be equal to 30 multiplied by the factor that is equal to pi over 180, because 1 degree is equal to pi over 180. And therefore, beta sub 1, which is equal to beta sub 2, shall be equal to 5 pi over 6 in radian. Furthermore, we are going to look at this figure. You can find that this angle shall be also equal to theta as well as this angle. And therefore, angle beta can be expressed in terms of the relation between these two and the total circular angle. Therefore, beta will be equal to 360 minus twice of the angle theta. And therefore, beta will be equal to 360 minus 2 times 60, because 60 is already computed as the value of angle theta. And therefore, beta shall be equal to 240 degrees. And in radian, this is equal to 240 multiplied by pi over 180, which can be simplified further into 4 pi over 3 radian. Now, considering the free body diagram of the post individually, let us try to imagine that we separate the post individually, so that we have here our free body diagram. Let us try to imagine, describe its free body diagram. Okay, if this will be the direction of the motion, then itong side na ito shall be the tight side. Tawagin natin itong T sub 1. At ito naman yung kanyang slack side. Itong T sub 1 na ito ay equal dito kasi dalawa naman ay magkakonekta. Ito rin T sub 1. At dahil itong belt will be rotating the direction, ito ngayon ang ating T sub 2 at siya naman ang tight side. Diba? And then itong coil na ito ay equal dito. Sa makatuwid ito ay T sub 2 rin at iikot yung belt in that direction. Sa makatuwid sa kabilang side naman, slack side siya. At ito yung kanyang magiging tight side. Now, if we're going to consider this part of the free body diagram, and then we apply the formula that the relation between the tension on the tight side to the tension on the slack side, which is W, and W is equal to 1000, shall be equal to A multiplied by F times beta. Na kung saan yung F is the coefficient of friction given to be equal to 1 over pi. Whereas this beta is equal to the angle subtended, which is equal to pi over 6. That if the two shall be substituted here, we can compute for the value of T sub 1, which is equal to 1000 times A times 1 over pi, or raised to 1 over pi times pi over 6. So that this can be simplified to be T t sub 1 equal to 1000 e to the 1/6, and then t sub 1 is equal to 1181.36. Now, kung puntahan naman natin itong part na ito, na kung saan t sub 2 is the tide side. Ito naman yung slack side. Therefore, the relation between the tide side and the slack side becomes t sub 2 over t sub 1 equal to e raised to fb. Kung saan yung beta naman shall be equal to b sub 2, ang value ay pi 4/3 pi in radian. That if the 2 shall be substituted, we already have computed for the value of t sub 1, which is 1181.36. So that this becomes t sub 2 equal to 1181.36 times e raised to 1 over pi times 4/3 pi, so that t sub 2 can be computed to be 1181.36 times e raised to 4/3, because pi here will cancel. So that simplifying, t becomes 4481.689. And then, on the third FBD, solving for the value of p, because the belt will be moving in that direction, ito naman yung kanyang tide side, at ito naman yung kanyang slack side, so that the relation between the two shall be equal to p over t sub 2 is equal to e raised to f multiplied by beta, where the value of t sub 2 is already computed to be at 4481.689. Now, substituting the value, we shall have here p equal to 4481.689 times e raised to 1 over pi representing our f and pi over 6 representing our beta. Then simplifying and solving for p is equal to 4481.689 times e raised to 1 over 6. And then finally, we have p equal to 5,294.49 pounds. Sa mga tuwid, lumalabas, ito yung pinakamalaking value, okay, na p na pwedeng i-apply dito, and that, okay, the weight will not still be moving. But it will start to move because a value larger than this one will now cause the weight W to move in the upward direction. Now, to solve for the other values of P, that is the minimum value of P, is that it is the value at which the weight is about to move in the downward direction. Kaya kung ipapakita natin ulit yung ating free body diagram, mababaliktad naman ang direction ng motion. Kaya ang motion nitong weight na ito is in this direction, mahihila nga nitong t sub 2 in that direction, at ganoon din mahihila yung p in that direction dito. Now, if we're going to examine the direction of the motion of the belt, therefore lalabas itong W natin will be our tide side, and this t sub 1 will be our slack side. Ganon din, ito naman, mahihila ito in this direction, therefore t sub 1 will be our tide side, and t sub 2 will be our slack side. At dahil nga hinihila naman siya pataas, t sub 2 therefore becomes our tide side, at p sub p will be our slack side. And if we're going to substitute the formula, the value in the formula, that the ratio between the tide side to the slack side equal to e raised to fb. Now, solving for t sub 1 becomes equal to w over e raised to fb. And if the value will be substituted, t sub 1 becomes equal to 1000 divided by e raised to 1 over pi multiplied by pi over 6. Pi will cancel, therefore t sub 1 becomes equal to 1000 over e raised to 1/6, and therefore t sub 1 is equal to 846.4817. Now, if this t sub 1 will be substituted here, and then we solve for the tension on the slack side of this particular FBD, therefore the ratio here between the tide side to the slack side is t sub 1, slack side is t sub 2, equal to e multiplied by e raised to f multiplied by beta. Now, substituting the value or solving for t sub 2 becomes equal to t sub 1 divided by e raised to f multiplied by beta. Therefore, value of t sub 2 will be equal to t sub 1 is substituted with this value of 846.4817 divided by e raised to 1 over pi times 4/3 of pi. Again, here, pi will cancel, therefore T will be, or T sub 2 will be equal to 223.1302. And then finally, okay, substituting the value in the formula for the ratio of T sub 2 over P, because in this case, ito naman yung kanyang magiging tight side. Samantalang ito yung kanyang slack side, therefore, T sub 2 over P shall be equal to A raised to F B. Then substituting the value of T sub 2, therefore, P will be equal to T sub 2 over E raised to FB, and therefore P shall be equal to 223.1302 divided by E raised to 1 over pi times pi over 6, and P therefore becomes equal to 223.1302 over E times 1 over 6. And then finally, P becomes equal to 188.88 pounds. And this is the minimum value P that will prevent that motion of that W. Nang ibig sabihin to, any value of P between the range of 188.88 and the value that we have already computed for the maximum will not cause W to move in any direction. It will remain stationary. And that gives us the answer in the problem.